Object detection is a crucial job in computer vision. Essentially, it identifies separate items in a picture. It does more than just recognizing them. Object detection tells us what objects are present and also pinpoints their exact spots using coordinates. These boxes help us know the precise location of each thing, and this is super useful in areas like watching over places, in robots, and many other applications. Let's visualize a picture. Two cats resting on a bed, and there are two remote controls beside them. When this image goes through our object detection tool, it smartly spots and pinpoints these items. Here is what we get. The system sees two separate remotes and is pretty sure about it, telling us exactly where they are with boxes. It also picks up on a big couch or bed in the photo. What's really cool that both cats are noticed separately, each with its own area, showing just how precise the system is. First, we are going to pull in some tools. Specifically, we are importing the pipeline function. After grabbing our tools, it's time to get them ready for our main task, spotting objects. We tune the pipeline function for object detection and pick the Zenova DET-R ResNet 50 model to help us doing this. Alright, with our setup complete, we give our image to the detector. See that threshold value of 0.9. That's us telling the system to only show us things it's really sure about, like 90% confident. Here we go. The detector worked through the images and here is what it found. Two remotes, what looks like a couch or bed, and of course our two cats. Each item has its own marked area, and with confidence scores all above 0.99, the system is really confident in what it has spotted. If you have a picture on your computer and it is not online, you can still use it. First, we turn the picture into a special link using url.createObjectURL of the file. This gives us a special link that our program can read. After we get this link, we pass it to our classifier. Okay, so for the implementation, we go to our web page, we go to the computer vision category, and we select object detection. Of course, we have a URL that we will pass to our object detection, and we will also support local image. Now, if we go to Visual Studio Code, I will open the object detection HTML. As usual, the first thing we do is that we create the script tag. We created with type module because we want to use the import statement inside it. And that's what we do. Then we import the pipeline function from this URL. Of course, you can get this URL from the installation section in the Transformers.js website. After that, we attach the pipeline to the window object. That's because objects created within a script of type module are only locally accessible. So in order to make the pipeline accessible globally, we attach it to the window object. Let's now go down to the initialize model. And in the initialize model, we initialize our pipeline. We tell it that you will use object detection, and then we pass the name of the model. Let me show you where I got this model from. So I'll go to the website of Transformers. I will go to the pipeline API, and at the very bottom, okay, so here you find the object detection. If you click on models, if you search for this one, you will find that it is the first one. So let's go back to Visual Studio Code. Of course, the initialize model is async because we are using await, and we are using await here because this function call for the pipeline will take time, so we need to wait for it. Okay, after that, let's go to the first button handler, detect image. We will get the URL from the input text, from this input text. Let me close this. Okay, then after that, We fire the detector and we specify the URL that we read from the text input. We specify a threshold of 0.9 to tell us only the objects that he is sure about them, over 90% sure about them. So if there is an object that it is 70% sure about it, it will not be returned. If it is 0.99 or 0.95, it will be returned. Okay, let's then output the result, convert the result to a string and output it to the output area. Okay, let's come back to our page and test that. Okay, so as you can see, these are the things that it detected: the remote, and the score for each one, and the box. This is for the coach, and this is for the cats. So it was able to detect all these options, very high confidence, and it specified their locations. Now, what if we have a local file, not a URL? That still can work. So we come back here. We first get the file selection input, then we get the first selected file from it. Of course, in our case, we only allow one file to be selected. Then we check if there is no file, then we alert the user and return. Next step, we use the URL object to create object URL on our file, and we store that in the URL object. Then we launch the detector, we pass it this local URL and the threshold 0.09, so only values that are more than 90% sure will be returned. And then we just convert the result to a string and store it on the output area. Okay, let's go and test that. So this is the cat's image. Detect. Now, detecting the images takes a little bit of time because it has to look at the image and identify each object inside it. Again, you can see we have the remote with high confidence and the box, the second remote, the couch, the cats, and so on.